Hello everyone, you are on VAEDO. मैं हूँ Viyakas. Let's learn. In this video, we'll learn about mass-energy relation, the most celebrated equation E that equals mc square. This is the sixth part of a special relativity series. For prior part, you can visit the link in the description. So let's begin. In this video, हम derive करेंगे E that equals mc square with some prior assumption and the result of Lorentz transformation and relativistic dynamics means mass variation equation. So to derive this result, let us consider that a mass is moving with some velocity, okay? And if we apply some amount of force F on the body, then जाहिर सी बात है due to this force the body will gain some kinetic energy dk. Okay, so we can write this change in kinetic energy as dk that equals to f dx. As from work energy theorem, the work done by the system is exactly equals to the change in kinetic energy and work is equals to f dx. So dk equals to f dx. Now f is equals to the rate of change of momentum, which is actually from Newton's second law. And if mass variable law, then we can write the Newton's second law as f that equals to m dv over dt plus v dm over dt. यहाँ पर हमने सेकेंड डेरिवेटिव फर्स्ट डेरिवेटिव ऑफ m कंसीडर किया है with dp over dt because m वेरिएबल है. सो फॉर वेरिएबल मास ये इम्पॉर्टेंटली हमें कंसीडर करना होगा dm over dt term. Then now we have to place the value of force in the first equation, then dk over dk that equals to m dv over dt plus v dm over dt into dx. Next we can consider that dk that equals to m dv dx over dt plus v dm dx over dt. Again, we may consider that जो change in kinetic energy है, which is actually related to dx over dt, and as we know, dx over dt is actually the velocity. v equals to dx over dt. So if हम अगर इसे replace करें, then we'll get dk that equals to mv dv plus v square dm. V square q, because in the second term we have dx over dt and v, so it will be v square, and first term dv already available tha and we have v due to dx over dt. So at final we have mv dv plus v square dm. Now let us consider the mass variation equation. हमें पता है कि जब हम किसी mass को velocity provide करते हैं तो it will change according to its velocity. For its derivation you can visit the fifth part of special relativity series. मैंने वहाँ derive किया हुआ है mass variation equation. So now consider the mass variation equation, which is m that equals to m naught over 1 minus v square by c square. Now squaring both sides, we get m square that equals to m naught square over 1 minus v square over c square. Then in further, after rearranging the equation, we'll get m square that equals to m naught c square over c square minus v square. In further, we can consider that m square c square minus v square in bracket that equals to m naught square c square, where m naught is the rest mass, means mass of the object, the position of rest क्योंकि ये mass variation equation में ही evident है, and c is the speed of light. Now the next step is to differentiate this expression from both sides. So the result will be m square in the bracket c square minus v square that equals to m naught square was c square. But as we know, m naught square and c square is a constant, so differentiation of this result will be 2m dm c square, because हमने m square को partially differentiate किया है, because if you get 2m dm in integration you will get m square again. So after the differentiation of this part will be 2m dm c square, and the next step is 2m dmv, because v square is variable and m is also variable, but m naught is constant, that's why we have 0 here. So in this situation, we can write this as 2m dmv plus 2v dvm square. Okay, because according to the rule of calculus, the proportion, ये दोनों multiple हैं, m and v, and both are variable. That's why we have m dmv in this term plus 2v dv m square, and it is equals to 0 because m naught and c जो है वो एक constant है. And as we know that differentiation of constants are 0. Now when we rearrange this, we'll get dmc squared, that equals to dmv square plus vdm into m. So vdv into m. Okay. So now as we know 2m actually cancel both sides क्योंकि ये दोनों side available था. Now if we recall our previous expression for kinetic energy, which is dk, that equals to mv dv plus v square dm, which can be written as, because हमें पता है ये term exactly equal है dmc square के, so you can replace this dk with dmc square. So finally we have the expression for change in kinetic energy, which is actually just in terms of change in the mass and c square. And as we know the c is a constant, so this is very interesting कि जो change in kinetic energy of the system है वो directly change in mass के terms में आ रहा है. So if we integrate this expression with the limits of rest mass and the moving mass, then we'll get this result dk with the integration limit of 0 and k, where 0 initially object rest में थी, so kinetic energy भी 0 होगी, and after that the kinetic energy is k. And mass, the limit of mass is actually m naught, which is the rest mass क्योंकि body initially rest में है, then after that is moving. So we have dmc square. At final we can write k that equals to in the bracket m minus m naught c square, because after integration we have limits of m and m naught, that's why we have m minus m naught c square. So the जो kinetic energy of the body है वो actual में change in the mass multiply with c square के directly equal है. So if we consider that ये जो change in kinetic energy है वो change in mass के equivalent है, so if we assume that कि m naught is the rest mass and m naught rest mass भी energy consider कर रही है, so the total energy will be k plus m naught c square. So if we add this value in the previous equation, we can get m minus m naught c square plus m naught c square. So the total value of energy will be E, that equals mc square, which is the most celebrated equation in physics, and because इसके जो byproducts हैं वो काफ़ी interesting हैं. आइंस्टाइन के इस इक्वेशन के फॉर्मुलेशन के बाद इसके बहुत सारे एप्लीकेशंस डेवलप हुए, स्पेशली इन न्यूक्लियर फिज़िक्स, और जो एनर्जी प्रोडक्शन, जो मास वर्सेस एनर्जी रेशियो का जो एक कॉमन परसेप्शन था वो भी चेंज हो गया. जो फंडामेंटल्स ऑफ फिज़िक्स है वो भी ग्राउंड ब्रेकिंग तरीके से ट्रांसफॉर्म हुई. सो नाउ we can consider some of the important application of energy mass equivalence. एक सिंपल से एग्जाम्पल से हम इसे कंसीडर कर सकते हैं दैट इफ़ यू कंसीडर द मास डिस्ट्रक्शन ऑफ ओनली 10⁻³ kg ऑब्जेक्ट, सिर्फ 1 ग्राम के किसी ऑब्जेक्ट को अगर हम डिस्ट्रॉय करें, मीन्स कन्वर्ट करें एनर्जी में, देन इट इज़ इन द ऑर्डर ऑफ 10⁻13 जूल और 10⁻7 किलोवाट आवर, जो कि बहुत ही ज़्यादा है, जो एक सब्सिडी की एनर्जी रिक्वायरमेंट के इक्विवेलेंट है. So we can estimate the strength of this equation that जब mass अगर completely destroy हो, then it can convert into very enormous amount of energy, and it has so practical utilization. अगर हम consider करें इसके practical utilization को in modern age, then in nuclear fusion जितने भी fission and fusion reactors हैं वो totally इस पर based हैं. Even जो हमारा fundamental energy sources है due to stars, बिकॉज हमारी जो एनर्जी सोर्सेज हैं वो स्टार्स ही हैं, वो भी बेसिकली इस इक्वेशन पर बेस्ड है, विच इज़ ई दैट इक्वल्स टू एम सी स्क्वेयर. सो दिस इज द वन ऑफ द मोस्ट इम्पॉर्टेंट transformation means achievement in the area of physics. If you really like this video, please like, share and subscribe and press the bell icon, जैसे कि फ्यूचर में कोई नई नोटिफिकेशन आपको मिलती रहे. Stay safe, stay
If you have any
curious.
que- if you have any query in this topic or the question, you can ask in the comment box. मैं आंसर करने की कोशिश करूंगा as soon as possible. If this video really helped you, so please like, share, and subscribe, and also press the bell icon. Stay safe, stay curious.